Okay, let's dive into section 10.2 then. Symmetry happens when one of those transformations we discussed on Tuesday maps a figure directly onto itself. So basically, when we perform this operation, what we get is the figure lands right on itself exactly with nothing different. Some examples will be shown with this letter H that we've got down here. And the types of symmetry that we're going to discuss will be vertical line symmetry, horizontal line symmetry, and rotation symmetry. These are the three types of symmetry that we are going to be concerned with. And essentially, what we're going to do to investigate that is if we want vertical line symmetry, well, let's see. Is there a place where I could draw a vertical line on this H? And if I were to perform that transformation, it would land directly on itself. And what I mean by that is if I draw a vertical line right here and we were to perform that reflection, if we were to reflect the figure we have across this vertical line, it would land directly on itself. When this happens, this is what we would call vertical line symmetry. And that H has vertical line symmetry because what's over here would land exactly on what's over here. And so we have vertical line symmetry. That's the basic idea of symmetry. And before I go forward at all, I want to give you a chance to ask any questions you might have about that whole idea. If that makes perfect sense, then great. We can go forward and talk about the next two. All right. With that in mind, I'm going to go ahead and just ask you a question then. Does this figure right here, this letter H, does it have horizontal line symmetry? And it's just a yes or no. I'm not going to do a poll. You can just type it in there for me, yes or no, whether or not it has horizontal line symmetry. And I don't mean drawing a line up here. I mean, is there anywhere that we could draw a horizontal line and have this land on itself? And I've got two yeses over there from Caroline and Nicole. All right, three. Emily now. It looks like Stephanie's coming in. Yeah, we could draw a horizontal line right here. And if I were to fold across that horizontal line, if I were to reflect this image across that horizontal line, sure enough, it would land directly on itself. What we have here would land directly on what we have here. And so, yes, we do have horizontal line symmetry. I think probably the most challenging of the symmetries is rotation symmetry. This one, we sort of have to visualize. It gets easier with practice. And like with a lot of things that we cover, don't overthink it. If I'm going to do rotation symmetry, then I'm going to put my center of rotation in the center of the figure. I'm going to rotate right around that point. So this is the point that's going to stay fixed, and I'm going to rotate. Now, if I were to rotate 90 degrees clockwise, I would end up with, let's see, if I rotate 90 degrees clockwise, my H is going to go this way. My horizontals are going to go vertical, my verticals, and that does not land on itself. So there I do not have symmetry. For a 90-degree clockwise rotation, there is not symmetry. This is a much tougher question, and if you don't know, it's okay with me. Is there anywhere that this figure right here, this letter H, would have rotation symmetry? Is there a way that I could rotate around this point right here and have it land directly on itself? And you don't have to be elegant in your response. Just kind of tell me yes or no, and if so, how far do you need to rotate it is kind of what I'm after. Wow, very specific and outstanding, Lorraine. You're exactly right. I was kind of, I was hoping for somebody to say like halfway around, because obviously if you go all the way around, anytime we rotate 360 degrees, we're going to end up right back where we started. So while you're exactly right about that one, Lorraine, we are not going to count 360 degrees as rotation symmetry because everything would have that. But the other one, the 180 degrees, if I were to rotate this 180 degrees, then I'm going to land right where it was. If I put this fixed and I rotate it 180 degrees, I'm going to end up with that. And sure enough, I'm going to have rotation symmetry, and I'm going to have it at 180 degrees. So this H over here is a great way of showing all three of these. We have vertical line symmetry. Well, not that line. We have vertical line symmetry because if we draw a vertical line down the middle, it would land on itself if we folded. We have horizontal line symmetry because if we draw a line there and fold it, it would land directly on itself. And then we have 180 degrees rotation symmetry because if I were to rotate around this point 180 degrees, halfway around, it would land directly on itself. 90 degrees didn't work, but 180 degrees did. So we would say, yes, that figure has rotation symmetry. Those are the symmetries we're going to talk about today. And we're just going to look at a bunch of different figures and make a decision on whether they have vertical, horizontal, or rotation symmetry. Some figures might have all three, like this letter H. Other figures might only have one or two of those types of symmetry. But basically, that's in the big picture, that is how we're going to approach this topic. Are there any questions about what vertical, horizontal, rotation symmetry are before we go forward and start looking at some figures? Excellent. Okay. So this equilateral triangle here, and I'm not going to ask you about this one. We're going to look at this one together. And we are going to be concerned with those three different types of symmetry. Vertical line symmetry, horizontal line symmetry, and rotation symmetry. So let's take a look at this equilateral triangle and see how this thing plays out. Vertical line symmetry looks like if I were to draw a vertical line right here, I could fold it, it would land directly on itself. So I would say, yes, this equilateral triangle does have vertical line symmetry. Now, if an equilateral triangle were drawn a different way, it might not. But this one does have vertical line symmetry. Here's what I mean by that. Horizontal line symmetry. If I try to draw a horizontal line through this thing, now if I try to fold it on itself, I'm not going to get the same figure. I'm still going to have an equilateral triangle, but this new triangle that I'm going to make, if I were to do a reflection across that line, my triangle would be oriented this way. And so it doesn't land on itself. So no, we do not have horizontal line symmetry here. Rotation symmetry. All right, well, the 360 degrees, that works for sure, but we're not going to count that one. And if I went 180 degrees, my triangle would be upside down. So 180 degrees is no good here. But my guess is you can imagine if I were to put my center of rotation right there in the middle, I can rotate this and have it land on itself. The question is, how many degrees would that be? And again, we're not going to get out a protractor or anything like that. Here's how I want you to think about this. You can imagine sort of having a handle right here on the center of rotation. And my daughter had a puzzle like this when she was really little, where it was the space for the triangle was carved out in the wood, and there was a triangular piece of wood that you could pick up and put back into where the triangle would go. And if you were to pick it up and rotate it, you could rotate it and get, this point would rotate and end up over here, and it would land exactly perfectly in that shape. And our question is, how many degrees is that? It's a hard thing to sort of think about at first, but bear with me here for a second. Essentially, that distance that I would have to rotate, however many degrees that is, that I need to rotate to get this point down here, I would have to do that again, and then do that again to get back where we started. To get all the way around, I would do that rotation 1, 2, 3 times. So to find out how far one of those rotations is going to be, because there are 360 degrees all the way around, and it would take 1, 2, 3 of those to get all the way around. I'm going to divide that by 3 and find out that 120 degrees is how far I would need to go to get this to land on itself. So I would need to rotate 120 degrees to move this point down here. And so there is rotation symmetry here if I were to rotate 120 degrees. Here's a tough question that you might, very good, Nicole, that you might get. Is there another number of degrees that if I were to start out with this point right here, is I know now that if I rotate 120 degrees, it'll put that point over here. Is there another number of degrees that I could rotate this point starting here at the very top and get it to land on itself? Something other than 120. I don't think this is an easy question, but if you happen to see it, I want to give you the chance to tell me. Let's see, 90, well, 90 would, let's see, if I go 90, that's going to make this horizontal line down here at the bottom vertical. If I went 90 degrees, I would end up with a triangle pointing to the right instead of pointing to the top. Let's think of it this way. Oh, outstanding, Lorraine, very good. Let's see how Lorraine got there. So if I want this point to go to here, that's a 120 degree rotation. What if I want this point to end up over here? Now, I could go 120 degrees counterclockwise, but let's just stick with the clockwise for now. 120 would get me here, and another 120 would put me here. So I need to do 120 plus 120. And if I go 240 degrees, this triangle is also going to land on itself. So this triangle would have rotation symmetry in 2 different places. If I do a 120 degree rotation, also if I do a 240 degree rotation, it will land on itself. I think the vertical and horizontal are probably fairly comfortable for you to digest. The rotation might take a little more practice, but just to kind of talk through it one more time. So the first thing I did was I can kind of look at this and see, yeah, you know what? If I turn it, I can get it to land on itself, but I don't know how far to turn it. You know, it's not like the letter H where I just need to go halfway around or 180 degrees. That wasn't so hard, but this one's tougher. What I do is I think, okay, well, all the way around would be 360 degrees. And if I think about this puzzle piece and I turn it and it clicks into place. I turn it again, it clicks into place. I turn it again, it clicks into place back where I started. Because it took 1, 2, 3 clicks to get back where it started, that's why we do 360 divided by 3 to find out the number of degrees for each one of those clicks. For each one of those rotations that clicks into place, it was 120 degrees. Once I know that, I say, okay, well, if I go 120 degrees, that puts my starting point down here. And if I go another 120 degrees, which puts me at 240, that gets my starting point over here. And so those are my 2 places where I have rotation symmetry. The next one would be 360. If I did, 120 plus 120 plus 120, that would put me at 360. And I would have rotation symmetry there, but we don't count 360 because that's going to be true for everything. Any questions about any of those 3 types of symmetry that we discussed for this equilateral triangle? Up next, I'm just going to ask you a whole bunch of questions about different figures and what types of symmetry they have. But before we go forward into that, I want to see if you have any questions about what we did on this one. Excellent. Okay, here goes. So there's a quadrilateral right there. The trapezoid, technically, but and my expectation is you're comfortable with that idea. But looking at this trapezoid, my question to you is going to be, what types of symmetry does it have? I'm going to set up a poll for this. And you're checking vertical line, horizontal line, and rotation. And those are our choices. Does this particular figure have vertical line symmetry, horizontal line symmetry, rotation symmetry, all of the above, or none of the above? Being able to identify the symmetries, that's the type of question you can expect to see on a quiz or an exam. I think the best way to approach these is to draw them. Maybe you're really good at visualization and you don't need to draw anything. If that's true, that's great. We'll go another 30 seconds and then talk about this one. These are the types of questions we're going to see today are, what types of symmetry exist in different shapes, different figures. All right, let's take a look and see where we are. Not unanimous, but close. Definitely strong agreement. Let's go take a look at this one. All right. So the things that I wanted to test for were vertical line symmetry. So that means, is there a vertical line I could draw and get this to land on itself? If I were to fold across that vertical line, does it land directly on itself? Yes, it does. So we can see here that yes, we do have vertical line symmetry. Okay, horizontal line. Now, if I were to draw a horizontal line through the middle and try to fold this on itself, you know what? I'm going to have the same shape, but if I were to do this, if I were to reflect it, if I were going to fold this, what I'm going to get is it is going to be the same shape, but it's going to be upside down from what I started with. And that's not landing on itself. So no, we do not have horizontal line symmetry. Rotation symmetry. Okay, so I need to imagine, like if I take this point right here and I rotate, is there a way that I can get it to land in a place that lands this entire figure exactly on itself? Well, if I were to go 90 degrees, I would wind up with that, which is not the same as what I started with. If I were to go 180 degrees, because that's one that worked with the H, so maybe 180 degrees. Well, if I go 180 degrees, get the same shape, but it's upside down, no good. And if I go 270 degrees, then I get a trapezoid that's pointed. Let's see, if I go 270, it would be this way. That's no good. And the only way I'm going to have rotation symmetry is if I go all the way around, and that one doesn't count. So the only symmetry we have for this particular trapezoid is vertical line symmetry. Poll went very well, but let me know if you have questions about how that's the answer we come up with for this one. All right, let's look at another one. This quadrilateral there happens to be a square. Same exact question is going to come your way. It'll take me a little bit to type it up, but that's okay. What types of symmetry does this quadrilateral have? This quadrilateral, happens to be a square. And so for this particular square, what symmetries exist is really what we're doing here. Let's go another 30 seconds, and then we'll talk about this one. All right, let's see where we are on this one. All right, perfectly unanimous. Outstanding. That doesn't happen very often. I think we're doing pretty good with the ideas of symmetry. That's great news. All right, just to sort of go through these with you, we'll start with vertical line symmetry. Is there a vertical line I could draw, get this to land on itself? Sure enough, there is. So we have vertical line symmetry. Is there a horizontal line I could draw? Yeah, I could draw one right through here. And if I were to fold across that line, it would land directly on itself. So yes, we do have horizontal line symmetry. And then finally, rotation. Let's see. Well, if my center of rotation were here and I rotate to there, it would land on itself. So yes, this does have rotation symmetry. And that's great. And that's all three. I do want to ask though, and I'm not going to put this in a poll, but I do want you to be able to find this. What is, if we're going clockwise, so we're just talking about clockwise, my question to you is, what is the lowest number of degrees that this would land on itself if we were to rotate clockwise? What's the smallest number of degrees we could go to get it to land directly on itself? In other words, what's the smallest number of clockwise degrees we can use to have rotation symmetry? Excellent, Caroline. 90 degrees. And you could think through that one a couple of different ways. You could think, well, let's see, I want this to get to here. So if my vertical becomes horizontal, and then the horizontals become vertical, it would land on itself. That's a 90-degree rotation. The way that I want you to think about this, and what I'm guessing happened here, is thinking of it as, okay, if I want this point to go all the way around, it would take 4 clicks, right? It would take one click would put me here, a second click would put me here, a third click would put me here, and a fourth click would put me here. So to get all the way around, to do all 360 degrees, it would take 4 clicks. So we'll divide by 4 and find out that each one of those turns is 90 degrees. Each one of those turns is 90 degrees. And so now that I know each turn is 90 degrees, to go from here to here is a 90-degree turn. What is the next place where I would have rotation symmetry? I would have rotation symmetry if I rotate 90 degrees clockwise. What's the next smallest number that would give me rotation symmetry? Because it has it at 90. What's the next smallest number that it would have rotation symmetry? (180 degrees? Perfect, because we could go, after that first 90, we could go 90 more and land over here and have 180-degree rotation symmetry. And then just to finish that off, we could go 90 degrees again and end up here. So 180 plus 90 would put me at 270 degrees, would give me rotation symmetry. Another 90 would be 360, and we don't count that one. So this figure would have rotation symmetry at 90, 180, and 270 degrees. Any questions about the symmetry that we just discussed related to that square? All right, let's do another one. We have this quadrilateral here. Happens to be a parallelogram. I'm going to ask you the exact same question about what symmetries does this parallelogram have? We'll go another 30 seconds and then talk about this one. See where we are on this one? Oh, wow, we are all over. Horizontal line didn't make the cut, but all the other ones got at least some support. Okay, that's great. Let's talk about this one a little bit. Not great in the way that you have this mastered, but great in the way that for us to discuss it. All right, so first we'll look at vertical line symmetry. If I draw a vertical line and try to fold this across itself, eh, gosh, it kind of looks like it, but you know what's going to happen if I do vertical line? And you could actually do this on a piece of paper. You could, draw it really dark and then, you know, um, actually fold it and flip it over is how this one would turn out. What's going to happen with this one is your parallelogram is going to be pointed the other direction. And so vertical line symmetry does not work here. Horizontal line symmetry. Well, you can kind of see if we do horizontal line symmetry, just sort of reminder of what we did Tuesday, this point would have to go perpendicular to the line and then the same distance away, it's going to move it over. And so again, we're going to, if we try to do a horizontal reflection here, we're going to also end up with our parallelogram going pointing the other way. And so that's not going to work either. So vertical line and horizontal line do not work. Now, if we look at rotation, okay, so I put my center of rotation right here in the middle and I rotate around. Now, I agree with you. If we go 90 degrees, it's not going to work because I'm going to have a parallelogram that's kind of vertical instead of horizontal. That's not going to work. But if I go 180 degrees, if I go halfway around, then this one is going to end up, if I go halfway around the whole circle, it's going to end up over here. And this one, if I go halfway around, is going to end up over here. And sure enough, if I do a 180-degree rotation, this is going to land right on itself. One way that you can see this is if you draw that parallelogram on a piece of paper and just sort of rotate it around 180 degrees, that you have exactly the same thing that you started with. This was a tough one. Vertical and horizontal line, probably not as hard as seeing that the 180-degree rotation does indeed work for the parallelogram. How about this hexagon? I'm going to do the same question for this one. I'll put up a poll for this hexagon. We'll go another 30 seconds and then talk about the symmetry of this hexagon. Let's see where we are on this one. Okay, now we're back in business. We're unanimous on this hexagon. Let's go ahead and take a look. So we start out looking for vertical line symmetry, and sure enough, if I draw a vertical line through the center of this hexagon, maybe better in the center, but you get the idea. We could fold it, it would land on itself. So we do have vertical line symmetry for this hexagon. And horizontal line, I could draw it right through there. And if we fold, it would land on itself. So performing a horizontal line reflection would give us the exact same shape that we started with, and that's how we get symmetry. And then rotation, well, if I put my center of rotation here and I go that far, it's going to land directly on itself. So sure enough, I do have rotation symmetry. And just sort of, I've asked this every time with the rotation symmetry, how many degrees do we have to go to move this point to here? And I'll just ask you that one and then I'll take care of the rest. How far do we have to go to move this point to here? How many degrees? We agree there's rotation symmetry. How many degrees? Okay, 45, halfway to 90, reasonable guess. So I have 60s. And let's take a look at that, how we got that 60. The way that we're going to do this, we're not going to use a protractor. We're not going to eyeball it. What we're going to do is this. How many of these turns would it take to get all the way around? And so there's one, there's a second one, 3, 4, 5, 6. So it would take 6 turns to get all the way around. 1, 2, 3, 4, 5, 6 turns to get all the way around. So I take the 360 degrees that would go all the way around the circle and I divide by 6 because that's how many turns it would take to get all the way around. And when we divide that, we get 60 degrees. So what that tells us is each one of those is 60 degrees from the other. So the first rotation I would do to get my point to move from here to here would be 60 degrees. If I'm listing out all of the rotation symmetries, I need to do the rest of them. So 60 degrees would get me here. If I do that twice, it would put me down here. So that's 120 degrees is also a rotation symmetry. If I were to rotate 120 degrees clockwise, this would land right on itself. And then if I do another 60 degrees, it would put that point here. Okay, so that's going to be at 180 degrees. And I do another 60 degrees, it would put my starting point here. Add 60, that's 240 degrees. Another 60 degrees would put my starting point here. That would be 300 degrees. And one more would put me right back where I started. We don't count that one as one of our rotation symmetries. So this hexagon would have rotation symmetry at 60 degrees, 120 degrees, 180 degrees, 240 degrees, and 300 degrees. Those would be all the rotation symmetries that this hexagon would have. Because if I started with a point here, and I do any one of these rotations, I'm going to land in a place that is the same. My shape is going to look exactly as it did when I started. Any questions about what we did with that hexagon? There is one other thing that I want to kind of discuss here briefly. The ones that I'm going to ask you about are going to be vertical line, horizontal line, and rotation symmetries. We haven't talked about this yet. You may see it here on this hexagon. We said, yes, there's vertical, and yes, there's horizontal. And you might be thinking, well, those are great, but wouldn't you have symmetry across this line too? You sure would. If you were to fold across that line, it would land directly on itself. It is possible to have diagonal line symmetry. It's just diagonal line symmetry is not going to be a focal point for us. I want you to be aware of it, that it can happen. For our class, we're focused on vertical, horizontal, and rotation. But if you happen to look at that figure and say, but what about that diagonal line? You'd be right. But that's just not going to be a focal point for us. one other thing I want to do, just kind of for fun. Oh, sorry about that. There's one other thing I want to do, not just for fun. These are kind of my favorite type of questions. Um, my what tend to be sort of really great questions, I think, is using flags from around the world and asking about the symmetry that they have. So, as we look at this flag, which I believe is France, um, what symmetries exist in this flag? And I'm going to ask you the exact same question that I've done with um, with the others. So, what symmetries exist on this flag? So, we're looking at this the same way we looked at those shapes. Where do we have vertical line symmetry? Do we have horizontal? Do we have rotation? Which of those do we have? And that's just a little heads up for the quiz that'll be this week, because I really like the flag questions. Like they're a fun way to look at symmetry. We'll go another 20 seconds on this one and then talk through it. All right, let's see where we are on this one. Okay, split right down the middle. That's unusual, but makes for interesting discussion. All right, let's talk through them. If one of the conclusions we reach doesn't make sense to you, please don't hesitate to ask about it. So the first thing we're going to do, and we're just going right down the line of the questions, is vertical line symmetry. So if I were to put a vertical line through here, I would agree that there is a left side of the rectangle and a right side of the rectangle. The thing is, if I were to do a reflection here, if I were to fold this, then the red would be over here and the blue would be over here, and that is not what I started with. So as far as vertical line symmetry goes, this does not have vertical line symmetry. And it's because the red and the blue would switch places, and so that means there's no symmetry. If we're to draw in a horizontal line, okay, and fold it, does it land on itself? Okay, now blue and blue match, red and red match, white and white match. So everything matches here. So this way, we do have horizontal line symmetry. So that would be a yes. Rotation symmetry. Right away, we can see it's a rectangle. So if we were to go 90 degrees, it would be the wrong direction. So that's no good. But if we went 180 degrees, if we went halfway around, so we put our center of rotation here and we turn it and go halfway around, how we're going to run into the same problem we had with vertical line. If I rotate halfway around, the red's going to be over here and the blue's going to be over here, and that is not symmetry. So rotation is also going to be a no here. So we end up with the only type of symmetry that this particular flag has is horizontal line. It's a fun way to ask this question because depending on the flag, it might have vertical, it might have horizontal, it might have rotation, it might have all three, it might have none. depending on the flag. So it's a great way to ask this type of question. Let me know if that didn't clear up um, anything that you might have thought about this one with the flag. All right, I was a little bit ahead of myself. There's one other thing I kind of wanted to do for fun, and that's to just look at symmetry of capital letters. And we're not going to do the whole 26-letter alphabet, but I kind of want to do some. Obviously, some of this depends on how you write them or how you draw them. But if I were to draw the letter A, which type of symmetry or symmetries would this have? Vertical line, horizontal line, rotation, all of the above, none of the above. And this one I'm not going to do a poll for. I'm just going to let you tell me. What type of symmetry would a capital letter A have? Vertical? I would agree. Horizontal is not going to work. It's going to flip it upside down. Rotation's not going to work. So the only place that the letter A would fall would be with vertical line symmetry. All right, now you have to imagine that my penmanship is perfect, and it wasn't, but imagine that I have this symmetrical, perfectly drawn B. What type of symmetry would it have? Genesis is given as horizontal, social horizontal. And this is just kind of a fun thing to do, and I think it'd be a great thing to do with kids, when you because symmetry is not a very difficult concept to visualize, and then we get to also look at something that's very familiar. I agree. Horizontal line. How about a C? Again, imagine that my penmanship is perfect with this C. What kind do we have? Horizontal. Okay, very good. I agree. Horizontal line symmetry for C. Um, what if I guess we looked at H before, didn't we? We looked at H before. H had all three, right? H would have a vertical line, it would have a horizontal line, and it would have a 180-degree rotation. There aren't very many letters that have all three of these, but H would actually land in all three places. And you could keep going with this and do as few or as many letters as you wanted to. I wanted to do enough that we kind of got the idea and see at least one that fits into each category. Um, but in the big picture, I think we're doing pretty good with our study of symmetry. Does anybody have any questions you want to ask about the symmetries we've talked about today, which is um, vertical line, horizontal line, rotation? Okay, very good.